While Pluto might have gotten a little demotion of its own back in 2006, that doesn't mean scientists aren't still curious about the dwarf planet. Despite not being a part of our solar system anymore, NASA wanted to explore Pluto even further and sent a spacecraft called New Horizons, which traveled for a long time until it finally reached the planet's orbit in 2015. But as the spacecraft took pictures and sent them back home, scientists noticed something different. Join us as we talk more about this faraway phenomenon and the fascinating discoveries NASA's made about Pluto. As we already know, Pluto was once known as the ninth planet in our solar system until 2006 when it was reclassified as a dwarf planet. It sits in an area called the Kuiper Belt, which is full of many icy planets and comets and is present beyond Neptune's orbit. When the International Astronomical Union came up with rules to define what a planet is, sadly, Pluto didn't meet the third rule to be classified as one since it hadn't cleared its orbit of similar-sized objects. Because of that, ultimately, Pluto was stripped of its status as a planet and is now considered the biggest among the dwarf planets. Back in 1905, an astronomer named Percival Lowell thought something was affecting the orbits of Neptune and Uranus, and he figured that there might be another planet causing these effects. Lowell made a rough estimate of where this planet could be in 1915, but sadly, he didn't live long enough to see it discovered. Pluto was finally found in 1930 by Clyde Tombaugh at the Lowell Observatory, and its name came from an 11-year-old girl in England named Venetia Burney. She suggested the name Pluto after the Roman god of the underworld to her grandfather, who shared it with the Lowell Observatory. And so, our solar system finally had another planet once again. It's no secret that Pluto is extremely far away from the Sun and is a dark and hard-to-see object following a long and stretched-out path around the center of our solar system, completing one orbit every 248 Earth years. Due to its long orbit, Pluto took until 1989 to make its closest approach to the Sun, and since then, it's been getting farther away and will reach its farthest point in 2113. This distance makes it really hard to see from Earth, and even with telescopes, it looks like a blurry brown disk without much detail. But do you know what doesn't look like a blurry brown disk? Well, our gorgeous little moon miniatures, of course. Hurry now and grab one for yourself using the link in our description box below. Now, even though it's distant and tough to see, studying Pluto properly can be tricky. But thanks to the New Horizons spacecraft and the 6 gigabytes of data we've received, NASA's finally realized that Pluto is not what we think. Because the probe was unable to orbit the planet, it couldn't capture its entire surface in pictures. But the heart-shaped feature on the planet is what caught everyone's attention. When the New Horizons probe saw this heart up close, scientists found out that it's actually a huge glacier made of nitrogen, covering 1 million square miles. The heart's left side is called Sputnik Planitia, and it appears to have forcefully shifted Pluto's position so that the basin faces its moon, Charon. This shift happened because of a process called true polar wander, and was caused by the massive weight of the icy glacier and Charon's gravitational pull that led to cracks and giant faults on Pluto's surface. Sputnik Planitia was formed in the northwest, and its current position wasn't accidental either. It moved closer to Pluto's north pole, and scientists think that if more ice builds up there in the future, the planet will keep shifting its position. Not only that, but aside from Pluto reorienting itself, New Horizons data also hinted that there might be a huge liquid ocean under Pluto's surface, which could be something like a water ocean. This discovery would make Pluto similar to ocean worlds like Europa, Enceladus, and Titan. And considering the tecton structures seen in the pictures from New Horizons, it's likely that this theory is true. Scientists believe that around 4 billion years ago, a massive object from the Kuiper Belt smashed into Pluto, which ended up creating Sputnik Planitia. This impact made a deep hole in Pluto's icy surface, and that's what caused a subsurface ocean to come up over time. The nitrogen ice settled on top of this ocean, which tells us that this liquid ocean might have come from a fast and violent beginning for the planet. Because of this, many researchers think that Pluto might still be geologically active. When they observed the cracks on Pluto's surface, they found out that these fissures ran for hundreds of miles into the planet's icy surface and were around 2.5 miles deep. Scientists believe these fissures were formed because of a freezing ocean beneath the surface, because when water freezes, it expands, creating pressure and cracking the icy shell. However, if the temperature drops enough, the ice can contract again, and 3D models of the planet show that Pluto does have the right conditions to make this happen. Even though there are no signs of contraction yet, these cracks suggest that the ocean is still freezing, which is possibly causing new faults today. If Pluto is active like this, it might mean that other dwarf planets in the Kuiper Belt could have oceans too, which could create more habitable places in our solar system. While the ocean might still exist today, it's likely isolated in most areas by about 200 miles of ice, so it probably doesn't touch the surface. But we do have reason to believe that in the past, it might have leaked through volcanic activity called cryovolcanism. The thing is, while Pluto could have been and might still be volcanically active, it's still nothing compared to Earth's volcanoes. Instead of hot molten lava like on Earth, Pluto might have had cryolava, which is a slushy cold material that once flowed over its surface. The dwarf planet's mountains called Wright Mons and Picard Mons might be the mouth of these cryovolcanoes, and areas like Viking Terra and Virgil Fosse also show signs of cryolava flow. In fact, the data from the New Horizons probe also showed evidence of ammonia-rich cryolava emerging from the mountains recently too. So, NASA's prediction of the planet undergoing active changes does seem to hold true. Because aside from volcanic eruptions, it appears that glaciers are also still shaping Pluto's surface. Pluto has glaciers made mostly of nitrogen ice that flow down from the highlands into the basin. These glaciers carve valleys as they move and are probably influenced by cycles of nitrogen ice turning into vapor and then freezing back onto the surface. Unlike Earth's glaciers, if these glaciers melt, they'll rise to the top because liquid nitrogen is less dense than solid nitrogen, which could even cause jets or geysers to erupt. Also, some of Pluto's surface is made of less dense water ice, so as glaciers move, chunks of water ice may rise up like icebergs too. But there's something unique happening on Pluto's giant glacier. Remember when we talked about Sputnik Planitia? Well, if you take a closer look at it, you'll notice strange, shaped patterns in the ice, which are each about 6 miles wide. Even though these polygonal shapes resemble cells under a microscope, they're actually proof of Pluto's internal heat trying to escape from beneath the glacier and creating bubbles of rising and sinking nitrogen ice, like a lava lamp. At the same time, warm ice moves up in the middle of these cells while cold ice sinks along their margins. Because of how rare these convection cells are, they're unlike anything we've seen on Earth's glaciers or anywhere else in our solar system. Even though Pluto is really cold and far away, its icy heart, also known as the Tombaugh Regio, has a daily cycle that drives its atmosphere and climate. Every day, nitrogen ice in this heart-shaped region turns from ice to vapor in the sunlight and then freezes back at night. The nitrogen winds circulate around Pluto at speeds of up to 20 miles per hour and move in a westward direction, which is opposite to Pluto's eastward spin. When these winds hit the rugged edges of Pluto's heart, it explains the streaks on the western side of Sputnik Planitia, which is quite surprising considering Pluto's atmosphere is much thinner than Earth's. Along with liquid oceans trapped under nitrogen ice, volcanic eruptions, and glaciers, Pluto also has hundreds of dunes about 45 miles along the western edge of Sputnik Planitia. These dunes seem to have formed recently and need small particles and strong winds to lift and move sand or similar particles. Despite its weak gravity, thin atmosphere, extreme cold, and icy surface, Pluto somehow managed to create dunes. And scientists think that they might be made of methane ice particles blown by winds from water ice mountains nearby. Now, normally, planets and moons have lots of craters, but Pluto and its moon, Charon, are different. They don't have many small craters, mostly just big ones. This surprised scientists because fewer small craters mean there are fewer small objects in the Kuiper Belt. But despite that, this discovery gives us clues about how the solar system formed and what compounds came together to build larger planets like Earth. Images from New Horizons also revealed two distinct features on Pluto's moon Charon. One of them stretched out like a huge plain while the other was rough and mountainous. NASA thinks that these topographical features were formed from an ancient ocean under Charon's surface that froze and expanded, leading to these terrains. A southward expansion created a giant cryoflow, while the northern expansion formed the rugged mountains. From Pluto being nothing but a fuzzy little telescopic to a world of stunning geographical landmarks, the New Horizons mission has truly transformed our understanding of the planet and its moons. But what do you think? Will NASA reconsider its decision to give Pluto its planet status again? And are there more secrets tucked away in the dwarf's stunning architecture?